Now, let's look at the 23rd problem. 23rd problem is find the points of discontinuity of the function where the function is defined like this: f of x is equal to sin x by x if the value of x is less than 0, it is equal to x plus 1 if the value of x is greater than or equal to 0. Again, we will follow the concept of left limit. So, left limit is for limit x tends to 0 minus. So, limit x tends to 0 minus means we need to use sin x by x because there is a function that is defined. So, this will be equal to limit h tends to 0. So, in the place of x, what are we supposed to do? Sin of 0 minus h divided by divided by 0 minus h. So, this will be limit h tends to 0. Sin of minus h is minus sin h divided by 0 minus h is minus h. This and this will get cancelled. So, limit h tends to 0, sin h divided by h is equal to 1. So, this you would have learnt last year. Since limit of x tends to 0, sin x by x is 1. Okay. Now, if you check the right limit, so for the right limit, what is going to happen? Limit x tends to 0 plus, so limit x tends to 0 plus is going to be x plus 1. So, this is limit h tends to 0. In the place of x, it is going to be 0 plus h and plus 1 is already existing. Now, in the place of h, substitute 0, this value will be 1. So, left limit is 1, right limit is 1. Now, what is f of 0? So, f of 0, we need to consider this function. So, substituting 0 in the place of x, f of 0 is going to be 0 plus 1, that is 1. So, from this we can conclude, since left limit is equal to right limit is equal to the function value, there is no point of discontinuity. So, depending on the way the question is asked, you need to answer it. See, if they ask you to discuss about the point of discontinuity, then you need to write there is no point of discontinuity. Suppose if they ask whether this function is continuous, then you need to say that this function is continuous. So, this is about the 23rd problem. Now, we will see the 24th problem. So, the 24th problem is determine if f defined by f of x is equal to x square into sin of 1 by x when the value of x is not equal to 0 and 0 when the value of x is equal to 0 is a continuous function. We need to determine whether it is a continuous function or not. So, for that what we will do is we will use the definition 1. So, so when will the function be continuous? When the value of limit x tends to c, f of x, if it comes out to be f of c, then the function is continuous at x is equal to c. We use the same logic here. So, instead of c you have 0. So, limit x tends to 0, the function is x square into sin of 1 by x. The reason why I took x square into sin of 1 by x is because x is the one which is not defined at 0. So, which is not defined at 0 will only have a limit, right. So, this value will be 0 square into sin of, you will have 1 by 0. See, when you write sin 1 by 0, remember when you have sin x, the value of x belongs to r. So, sin 1 by 0 is going to be sin infinity. Sin infinity doesn't mean infinity. Sin of any number in the real valued system is what is getting substituted here. So, what is that you have is 0 square into, see, this is a very important concept, have it in your mind. Sin of any value that you are substituting from the real number system will always be a value that is between minus 1 and 1, because what is the range of sin? The range of sin is between minus 1 to 1. So, you have 0 square multiplied with a finite number. Okay, don't make the mistake of writing sin infinity as infinity, because sin, the maximum value it can generate is plus 1, the least value it can generate is minus 1. So, 0 square into a finite value will be a 0. Now, what is f of 0 here? So, f of 0 according to the question is still 0. Since limit x tends to 0, f of x is equal to f of 0. This is also a continuous function. This is a continuous function for all values of x that belongs to R. So, there is no point of discontinuity at all. So, observe, he has asked whether it is continuous or not. So, you need to report it as whether it is continuous or not. Whereas, in this problem, he has asked about discontinuity. You have to say there is no point of discontinuity. So, this is all about the 24th problem.